morning, good afternoon, good evening. Whatever the case may be, we are back and better than ever. And today we are talking about axes, intercepts. Let's get to it, shall we? All right. Of course, axes, intercepts are where the graph of an equation or function intercepts the x and y axes. So for a parabola, it could look something like this. All right. And those can be quite powerful in helping us to graph quadratic functions. The y-intercept, if we are in the form of ax squared plus bx plus c, then the y-intercept is always going to be c. Why is that? Well, if you know, the y-intercept is, of course, on the y-axis, right? So any coordinate on here has the equation, or has the ordered pair 0, whatever the y-coordinate is, 0, 0, 0, whatever the y-coordinate is. So that means within the function, if we let x equal 0, goes away, and all we are left with is the constant. So for example, here, the y-intercept is -3, because if x is 0, here and here, we're just left with -3. So the x-intercepts, if I am in the form y equals a times x minus alpha, x minus beta, then the x-intercepts are alpha and beta, right? Y equals x minus 2 times x plus 3. If I set that equal to 0, think about that. I let y equal to 0 to solve, then I get x equals 2 or x equals -3. I let y equal 0. So any point on the x-axis is going to have the coordinate something 0, something 0, something 0. So what we're saying here is you let y equal 0, solve for x. Those are your intercepts. So that's all there is to it, particularly when it's factorized. So find the x-intercepts of this. Well, to find the x-intercepts, we let y equal 0. Oh my gosh, it's almost the exact example I just gave. If I let x equal 0, and you don't even have to really write this out because you can just look at it, correct? The x-intercepts would be 3 and -2. And I'll graph that for you once that one warms up. What about this one? What would it take for y to be 0 here? Well, that would simply be x equal to 4. Okay, and you might think, well, wait a second, it's squared. Well, now the squared, this is inside the parentheses that it has to be 0. So the only possibility here is x is equal to 4. So let's just take a look at those. It's going to wind up here, almost done, and give us the option of what kind of window that we want to see. Giddy up, giddy up, giddy up. Come on, come on, come on. All right, here we go. So we are going to ask us to give us the graphing window, and that first was 2 times x minus 3 times x plus 2, 2 times x minus 3 times x plus 2, and our intercepts are, boom shakalaka, look at that, right there, it's 3, and right here it's -2, just like we had said. And then this next one was negative x minus 4, the quantity, squared, boom, and it touches the x-axis at x equals 4, just like we had predicted. Onward. Sometimes we'll have to factorize to find the x-intercepts, so that would be, we just let x equal 0, so x squared minus 6x plus 9, that's going to be x minus 3 squared, so my x-intercept here is going to be 3. And here we have 0 equals -x squared minus x plus 6, or if I multiply through by -1, x equals x squared plus x minus 6, so this would be x plus 3, x minus 2, and we get the intercepts at x equals -3 and x is equal to 2. No big whoop, right? All right. Let's see what else we get here. You can graph that on your own. I'm not going to take time on the videotape to do that. But you can go to your graphing calculator and graph these just to convince yourself if you are unconvinced. So let's go ahead and graph from axes intercepts. Sketch the graphs of the following functions by considering the value of A. So AI, the value of A is equal to 1, which means it's going to open upwards and it's going to have the shape, the general shape of y equals x squared. AII, the y-intercept is -3. Y-intercept is -3. So let's go ahead and plot that. 1, 2, 3, right there. And the x-intercept, AII, is going to be, set this equal to 0, so that would be -1. And, oops, what am I doing? I went to part B. This is A. What are the x-intercepts? So I have to set that equal to 0, x squared minus 2x minus 3. So sorry about that. So 0 is going to be x minus 3 times x plus 1. So my x-intercepts are going to be 3 and -1. So 1, 2, 3, and -1 right here. And here's a nice little thing that you should realize. The axis of symmetry is going to be halfway between the x-intercepts. So I know my axis of symmetry is here, okay? Which means that I have another and even extra point there. That's kind of cheating according to the instructions, but there she blows. There is the graph of y equals x squared minus 2x minus 3. And I added a second page here just to give us a little bit of room. Okay, so what do we need? The value of A, that's going to be negative because x times x is x squared. So, so this is BI here. If I were to FOIL this, I would have y equals -2x squared and then some other stuff. But this is all I care about here, the value of A. So A equals -2. That means my parabola is going to be open downward, and it is going to be steeper. Ooh, I got to go see Dr. Martin tomorrow morning. It's going to be steeper than y equals x squared. BII, what are my y-intercepts? Well, here I just have to think about it. I just have to let x equal 0. So that would be -2 times 1 times -2 if these x's are 0, which is 4. So I have a y-intercept of 4, 1, 2, 3, 4, right there. Very good. And what else? Ooh, the x-intercepts, those are the easy ones this time because it's just whatever's going to make this 0, and that's going to be x equals -1 and x equals 2. So -1 and 2, and so the axis of symmetry is halfway between. That's going to be at 1/2. So my graph looks like something like that. I kind of missed some spots there, but you can see how it's steeper than your normal x squared curve. Isn't that lovely? It's just fantastic. And then our last example, sketch the graph of y equals 2 times x minus 3, the quantity squared, by considering. Okay, so A, the value of A. So if I were to expand x minus 3, the quantity squared, I would have x squared minus 6x plus 9, but all of that times 2. So anyway, my A, I don't have to do all of that, but my A is going to be +2. So that means my graph is going to be open upwards and have the same steepness of just plain old, oh no, it's not going to have the same steepness. It's going to be steeper than y equals x squared. My y-intercept, well, if I let x equal 0, I get 2 times -3 squared, right? So that would be equal to 18. So I'm going to have to make each of these guys worth 2 here to be able to get the y-intercept. So 2, 4, 6, 8, 10. I'll make that 10. 12, 14, 16, 18. So there's my y-intercept. And then my x-intercept is 3. It just touches it. Okay, that's going to be touching the x-axis at 3. 1, 2, 3. And since it's touching, I know that's the vertex. Oh, the y-intercept. I didn't have to go through all. Oh yeah, I did have to go through all that. So anyway, it's just touching, and I can. This is my axis of symmetry. If I want to have a cheat point, I can go 1, 2, 3 away here, so I know I have a mirror image over here, and then I can get a nice smooth curve like that. All very great strategies when graphing quadratics. Hope you enjoyed it. I know that I did. Let's see how Natasha's doing. Is she still unwritten? I bet you she is. I will take this opportunity to simply say that I am